Lesson 4, we're omitting 2 and 3, so we're just going right to 4 from 1. Okay, so the next 3 lessons will involve the conversions of units to the SI system. SI system, just so you know, that's the metric system. Okay, imperial system is yards, feet, miles. Okay, the U.S. uses it, only people that use it really. Okay, so method 1, using the SI chart. Method 2, proportional reasoning, and method 3, unit analysis. Okay, unit analysis is going to be the one that I feel like you need to be good at for sure, and that's probably the most confusing. Proportionals is just cross multiplication, so when you're solving algebra, if you remember cross multiplication solve, you'll be fine. Okay, and then 1 is using the SI chart, which is just using this chart here, which you're given on your formula sheet. Okay, if you're wondering what do I get for my test, that back page of your book, that formula page, is what you get. Okay, so that little bar line there, that is the conversion chart. Okay, we're going to talk about that here. Okay, so that's lesson 4. Lesson 5, conversion between SI and imperial. Lesson 6, conversion involving square units and cubic units. All right, so conversion of units within the international system, so the metric system. This is the chart I kind of pointed to yesterday, so you could kind of do that first page of your worksheet. So the biggest thing is just understanding that meters, grams, and liters. Okay, so meters is what type of measurement? What is it measuring? Distance, right? Length. Okay. Grams is what type of measurement? Weight, mass. Liters? Volume, technically, right? Okay, volume, because you can have a liter of sand, right? Technically, okay, volume-wise. Okay, so then just knowing that's what these lines are. So these right here are your meters, these are your grams, and these are your liters here. So these are just the lines for those different type of measurements. They're not additional, okay? They're the same. Like this is still centimeter, centigram, centiliter. It's all the same, it's just different unit, okay? So don't be confused by that. So what we want to get good at is 1 gigameter. So giga is the big one here, is how many meters? Okay, is a gigameter bigger or is a meter bigger? Meter. Yeah, giga is bigger, so what's going to happen is 1 gigameter is going to make a lot of meters. Understanding that the unit you have is either bigger or smaller than the unit going to. That will determine is your number getting bigger or getting smaller. So this one would be, obviously, it's going to be that number there, which is 1 billion. So 9 zeros. A lot of zeros, yep. 1 with 9 zeros. 1 megameter. So again, megameters on the left, it's bigger than the regular, so it's going to be a bigger number. It's 10 to the 6, which is 1 million. So 1 megameter is 1 million meters. Okay, we should be good with kilometers. How much? It's 1,000, right? Kilometers 1,000. You can see that right there. 10 to the 3, 1,000. Just reading the chart right now. Okay? So now we have centimeter to meter. So what's bigger, a meter or a centimeter? A meter is. So 1 centimeter is going to be a really small meter. It's going to be a smaller number. Okay? That's why it's 0.01. 1 centimeter is 0.01 of a meter. Because 0.01 is what is a fraction? 1%. Yes. 100th, right? 100th. Okay, 1%, 100th, right? So we know centimeters, there's 100 centimeters a meter. If I have 1 centimeter, I have 100th of a meter. That's a 100th. 1 millimeter is not 100th, but 1,000th, which we write 0.001. 1,000th in the thousandths place. So why did we spend yesterday going over place value? You kind of said, yeah, I know that, but you didn't. You know that. Okay, make sure you know that's your thousandths place. Micrometers. So we're way over here, this little funky m here. Okay, that is 10 to the negative 6, so that's going to have 5 zeros in front of the 1. Okay, which is 1, 2, so tens, hundreds, thousands, 10,000s, 100,000s, millionth. Yeah, 1 million. Okay, so you can see micro and mega are kind of related. This is 1 millionth. This is millionth. 1 over a million, a million. Okay, and then 1 nanometer is the really small one, which is the other side of giga. So it would be 0.000 8 zeros in the 1. Okay, that'd be 1 over billion. So 1 billionth. It's the billionths place. Okay. Any questions so far? Just setting them up using the chart there. Okay, so then 1 liter. This is where it gets a little tricky here. So, well, these ones are tricky. I think the next one's a little bit. 1 liter to milliliter. So 1 liter, so we're here, to milliliter. So here, 1, 2, 3. So it's going to be, is a liter bigger or smaller than milliliters? Bigger. So it's going to be 1,000.001. Because 1 liter equals 1,000 milliliters. Right? 1 liter equals 1,000 milliliters. Same thing. 1 gram is 1,000 milligrams. Okay, and what they did now is they shifted it on you. We're now at kilograms, so we're here. How many kilograms are in 1 gram? 1,000. 1 kilogram is 1,000 grams. Okay. 1 milliliter equals how many liters? So now we're getting smaller. Yep, so 1,000, so that's pretty much this right here, isn't it? Same thing, milligram to gram. And then 1 gram to kilogram is the same thing. Again, it's 1,000. Okay. All right. Questions so far? Okay. So, for example, to convert from kilometers to centimeters, we move 5 positions to the right. Okay, so 1 kilometer equals 10 to the 5th. Okay, because they're 5 apart. What do you mean? Well, here's centimeters. 1, 2, 3, 4, 5. I'm on kilometers. That's how you use that chart in your book. Okay, it tells you how many places they are apart. Okay, so same thing. If I was going from centimeters to kilometers, I would go, okay, sorry, I counted that way already. This way would be 1, 2, 3, 4, 5. That's a positive. This would be a negative. I'm going left. Okay, so we're going to use this chart to do these ones. So I'll pause it right there. So 1 meter into centimeters. So if I'm here at 1 meter, that meter's the middle. I'm going to centimeters. It's 1, 2, and it's to the right, so it's a positive exponent of 10 squared. We're not timesing it by anything because we're just going from 1. It's just 1 times 10 squared. You don't have to do that. We'll do it down here for 7.5. So essentially, 1 meter, which we know this is redundant, is 100 centimeters. We know that, 10 squared. Okay, 1 millimeter to meter. 1 millimeter to meter. So which way are we going, left or right? We're going left because we're here and we're going there. So we're moving it left 3. So it's going to be 10 to the negative 3. Okay, if you're not sure, I'm talking about I'm here. I'm going to meters. 1, 2, 3. Okay. Yeah. Right. Because the third spot is where the number is. Yeah. 1 liter equals milliliter, so we get bigger or smaller here? Bigger, right? And so this one would be 1,000. So 1 liter is 1,000 milliliters. Okay. So I'll leave this here so we can still use that chart. So again, we got to figure out which way are we going. So it's as simple as saying, okay, 7.5 meters to centimeters. Okay, so I'm here at meters. I'm going 1, 2 to the right for centimeters. If I'm going right, my number is going to get bigger. It's simply going to be 7.5 times 10 squared. I moved 2 spots to the right. Right means 2 for your positive exponent. So So then essentially, if you write that, it wants that to be an actual measurement. 7.5 times 10 squared is going to be 750. There's 750 centimeters and 7.5 meters. That makes sense. Okay, so I'm going from milligrams to kilograms now. So I'm here at this M. Here, 1, 2, 3, 4, 5, 6 to the, which way? Left. So that means I'm doing that. 7 to 350 to the negative 6 because it's left. Makes sense. Milligrams are smaller than kilograms. So we should get a smaller number. Okay? And so what you can do there is you can put that on your calculator if you want, or you can just move the decimal 6 spots. Right? Your decimal's just going to, your decimal's right here. 1, 2, 3, 4, 5, 6. So it would just be that with a 0 in front. Say that again?
That's because that's not the one with the. It's not.
Yeah. Are we okay? Sorry. I'm still catching up, but it sounds like you guys got it. Yeah. Okay. Okay, so 325 micrometers to nanometers. So that means we're here, and we're moving 1, 2, 3 to the right. So it's going to be a positive. So it's going to be 325 times 10 cubed. So essentially, we're going to add 3 zeros. Because the decimal's here, we're going to move it right. So 325,000 nanometers and 325 micrometers. Okay, questions or concerns yet? Yeah.
Can you do that if you don't have that graph?
The only thing is, I think you could do it from, I think you're probably pretty comfortable here. But I think just remembering these ones would be harder because they're not very common. So I mean, we know what milli is, we know what kilo is. Okay, you know what the hecta, that's a little bit new, but we know what centa is. So I mean, a lot of them you know. So I mean, yes, if you have a good grasp of those. But you'd obviously have to know that mega and giga were 6 and 9 would be the big thing. Okay, so let's do this last example here for this kind of piece. So convert the following, leave the answer in scientific notation. So remember, the biggest thing in scientific notation is scientific notation numbers are between what? I talked about this yesterday. 1 and 10, right? This is a 12. So we're going to have to change a little bit. So let's just do the basic, though. Let's just write 12 times kilometers to millimeter. What is that going to be? Kilometers to millimeters. How far? 6. Good. So times 10 to the 6th. Now, if I need to make this 1.2, that means I'm taking this decimal, moving it left 1. To balance that, I need to add, do I add 1 or subtract 1? I add 1, good. So it's going to be 1.2 times 10 to the 7th. Because it's the opposite idea. I move this decimal to the left, so I need to move the exponent to the right, which is adding 1. By moving to the right, you're adding 1. 6 plus 1 is 7. Okay, another way you can think about it is that I was at 12, now I'm at 1.2, so to get back there, I have to go plus 1. 2, 3, 4, 5, 6, 7. Okay, just understand that kind of opposite idea. Okay. So let's say it one more time. We can't use 12 because 12 is bigger than 10, so we had to move this decimal to the left 1. We moved it left 1, therefore we have to add 1 to our exponent to balance it out. Left means negative 1, so we need to do a plus 1 to our exponent to balance. We can't just move left 1, left 1. That wouldn't make any sense. That means we're changing the number. Okay, so 580 megagrams to gram. So 580 megagrams. So what are we moving that to? How far is that? 6, right? Negative 6. Good. So it's going to be negative 6. We can't use 580 for using scientific notation, so we have to move it over twice. 1, 2, so we have minus 2, we have to go plus 2. 5.8 times 10 to the negative 4. Don't be messed up by the integers there. Negative 6 plus 2, right? So it's 10 to the negative 4. All right, 15,700 centiliters to megaliters, a big M. So that's a megaliters. So what's that going to be? 8, good. It's 2, excuse me, 2 plus another 6 to the left, so negative 8. So then we're also going to go 1, 2, 3, 4. So we're going to have 1.57 where we subtracted 4, so we add 4. 1.57 times 10 to the negative 4, and that's megaliters. Sorry, it's important to put these here. Should have that there, we should have G there, and we should have MM there. Okay, so that was method 1, using the unit number line, okay, to convert SI units. So essentially counting a lot of exponent work, okay? Method 2, okay, compare yourself. It's kind of like the least favorite, but we'll kind of go through it still. Using proportional reasoning with SI units. So this is a lot of cross multiplication. So setting things up so that you can say, if we know that A over B equals C over D, we can cross multiply and solve for what's missing. So here's an example of doing that. So Alice, Jim, and Rima were asked to convert 300 centimeters into meters. Okay, it's a very simple thing. You guys already know the answer is going to be 3, but we're just going to show in terms of the basics of the work of what they're doing. So first off, Alice, she did more of like a common denominator approach. If 1 meter equals 300 centimeters, you know x equals 300 centimeters. Well, make the bottoms the same, so times by 3 to both top and bottom. That gives you 3 meters is 300 centimeters, which that's your answer now. By multiplying, getting the essentially a common denominator type deal. I don't really like that one at all. I prefer the cross multiplication. So for cross multiplication, you go 300 times 1 equals x times 100. Then you just divide the 100 over. Okay, the centimeters cancel. 300 by 100 is 3. 3 times 1 meter is 3 meters. So it's cross multiplication there. So again, their first step, let me highlight this one more time. Their first step is they went 100 centimeters times x, 300 centimeters times 1. That's why these are here. Then they divided the 100 over, canceled the unit of centimeters. 300 over 100 is 3, and you have the 1 meter. 3 times 1 is 3. Okay, hers is very similar. She just flipped. So she just has her centimeters on top. That's the only difference. So you still cross multiply. You still get the same setup. You still divide. You still get that. You still get 3. It's really the same thing. It's just flipped, just showing it doesn't matter what's on top. Centimeters or meters, it doesn't matter. Okay, so this is proportional reasoning. So their notes on it, Alice method is very difficult to use if the multiplier isn't not a whole number. So like we're not going to get super friendly stuff like this all the time. You could get like 12.7 or something, which would not be very, wouldn't be very easy. Jim and Rema use cross product, which is fine. And then the other thing you can understand is if you don't want to be confused by the units, you can make sure that you line your units up. So you either have to have your units right on top of each other, so like meter over meter, or right across from each other. If I have my meters here and here, I messed up. Okay, they have to be compared or across, or compared or across. It doesn't matter. So looking at this example, I'll show you. So we won't use the units, okay? So we're going to say we know we have a photograph. There's one like this on your second part of your assignment today. The photograph of an African elephant has 1 centimeter of it represents 0.6 meters. So 1 centimeter on the graph, on the picture, means 0.6 meters. So I know my centimeters are on top right now. Okay? And then it says the elephant's trunk is 3.5 centimeters. That's centimeters, it's on top. Meters on bottom. We want to figure out how long the elephant trunk is in meters. That's all I did there to set that up. So essentially, this is the meters, this is the centimeters. This is the picture, this is the actual. That's how you put up your setup. So now you just cross multiply. X times 1 is just x. 0.6 times 3.5 is 2.1. X is 2.1 meters. So that means that the trunk in real life is 2.1 meters. So about almost 7 feet. Okay? Is there any questions with that? This is where everybody kind of went bonkers. I kept the units in it last class, so they got pretty confused. So yeah.
Why do you write it in meters, not centimeters? Just because it's...
What, in meters?
Yeah.
Okay, the answer's in meters because we are given the centimeters of the picture. So the missing piece, this is a meter, right?
Okay.
That's right. So the answer we're trying to get is in meters.
And then because you multiply each one by a centimeter, the meter, they cancel.
Right. So if you left the units in there, and I did this last class, but it made things really ugly.
But they cancel.
Right.
Make sure you multiply each one by a different.
Yeah, because this is centimeters here, and this is meters, or excuse me. Yeah, this is meters. That's centimeters. That's centimeters. So when you multiply here and here, the centimeters essentially cancel. So what's going to happen? And that's why in the piece before, they're kind of saying you can drop those so you don't overwhelm yourself. But in unit analysis, it does a better job of organizing the units, and I think you might like that one a little better. Okay? All right, so 2.1 meters is the answer there. Example 6, Reba followed a recipe for a rice bean soup and used 175 milliliters of beans, 650 milliliters of rice. She realized she had not made enough soup, so she added 70 milliliters of beans to the soup. How much rice should she add? Okay, so how would you set this up? What's the setup? Proportions, right? What's the setup? Yeah. So this is the setup. 245 is the answer. Yeah. So, or no, it's 260, but it's close. So this is the setup because we take what they gave us, right? We know that the recipe requires this proportion. That's what they told us. The recipe requires 175 milliliters of beans, 650 of rice. She had 70 beans. We're not sure how much rice, so we're setting these up because we want them to be equivalent proportions. That's why they're equivalent fractions. So now we just cross multiply. Okay, 650 times 70 equals 175x. Okay, so this is the recipe. That's the recipe. This is the added. This is beans. This is rice. So everything's related. Beans, rice, the recipe, the added amount. Okay, and so all we have to do now is we just have to multiply these two numbers. Can somebody do that for me? I think it was 4550.
4550.
Yeah, 4550.
Or another zero. 45,500.
Okay. Divide by 175. Divide. You get 260 is how much rice she should add. So you have 260 milliliters of rice she should add to balance out her recipe.
You have to say up, right?
Yeah. Okay, so that's method 2. So essentially method 2 is cross multiplication. Okay, setting up proportions is what method 2 is. Questions, concerns yet? I think you guys are getting the benefit of me doing this twice because I'm not doing the same things that made them mad. So maybe make it easier for you. All right, so method 3, doing SI units, so using unit analysis. So unit analysis is essentially you times what you're given by the conversion. So, for example, if I want to know how many 75 millimeters to meters, I go 75 millimeters over 1 times 1 meter equals 1,000 millimeters. So what happens is when I multiply them, the millimeters cancel. It's 75 over 1,000, which is 0.075. Same thing as moving it over 3, right? That's an easier one. Okay, so you put what you're given times by the conversion. Okay, so I'll show you here. So convert the following. So 12 kilometers to meters. So I'm going to go 12 kilometers, that's my given, times, and then I'm going to go 1,000 meters over 1 kilometer. And so it's called unit analysis because we're comparing the units in a way that kilometers will cancel because we want the answer in meters. 12 times 1,000 is 12,000. 1 times 1 is 1. So we really get 12,000 meters. Unit analysis. Okay, so this guy, 2730 nanometers over 1. And then we want to go times nanometers, so it's going to be 1 meter has, nanometers was a big one, so that's going to be 10 to the 9th N, right? Okay, so what happens now is the n's cancel, we multiply these, so essentially you're going to have 2730 m over 10 to the 9th. Well, go back to fractions, or excuse me, let's go back to fractional exponents. Okay, what else is 10 to the 9th at the bottom is the same as what? Well, it's a negative 9, right? So this just means we move it over 9 spots to the left. Okay, so just understanding this, these are the same thing. This is this. Okay, so here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5 zeros. That would be your answer there. Okay, unit analysis is particularly useful when multiple conversions will be required. Unit analysis can do multiple conversions in one calculation, as shown below. For example, to convert 2.4 kilometers to millimeters, you would first convert kilometers to meters and meters to millimeters. Okay, because meters is kind of the middle guy. So it's 2.41 over 1, 1,000 over 1 kilometer, 1,000 millimeters over a meter. And so then when you would just multiply, this would cancel, this would cancel. And so then you multiply all those, that's all 1, so you'd have that big number there of 2.4 million. So there's 2.4 million millimeters and 2.4 kilometers. Okay, obviously you guys are saying, well, can I just count like we did earlier? Yeah, you can. That's the other way. This is a different method. This is unit analysis. Okay, so this is the third method. We only have 2 examples left. We're doing much quicker than last class. Okay, any questions? We're sure? Okay, so let's do these last 2 examples. All right, so we're going to go 0.25 gigameters to megameters using unit analysis and known conversions. So we want to go giga to mega. So there's 2 ways you can do this. I'm going to do it the way with 3 of them. So what I'm going to show you is I'm going to go 0.25 giga over 1. That's the given. I'm going to convert this to meters. So giga we know is 10 to the what? 10 to the 9th, right? Right, 10 to the 9th meters in 1 gigameter. And then I'm going to convert meters back to megameters. So I'm going to go, sorry, this needs to be smaller. Just a little bit more lowercase m because I'll have megameters coming. Okay, and 1 megameter is how many meters? 10 to the what? 6th. Okay, so now we have it set up. The important part I want you to see is if you have 2 units left still, you're in trouble. What am I saying? Look, gone, Gone. What's my answer going to be in? Megameters. What they ask it for in? Megameters. Okay, so now we just multiply across. Okay, I can do something quickly though. What's one quick thing I can do? Yeah, 9 over 6 is a what? 10/9 minus 10/6, 10/3. Nothing's on the bottom now. I simply go 250 megameters. Why is it 250? 1, 2, 3. You can also use your calculator and times 10 to the 3. That's fine. Okay. So again, what they did was, I'll go back to the top. They took the given, they just put it over 1. They compared it to meters. So 10 to the 9th meters is 1 gigameter. Then they compare it to megameters. 1 megameter is 10 to the 6 meters. I guess my meters are cancel, my gigameters are cancel. I'm left with my megameters. I simply just multiply. You can just multiply if you want and divide by 10 to the 6, but I'm hoping your exponent rules aren't that rusty. 9 over 6 is just 3. Okay. All right, now we're going to mix it with, this is where it gets, this is the last one, but this is where it gets much harder in terms of, as we keep going here. We have speed now. So Zimmer need to convert 50 meters a second to kilometers a minute. So he wants to take the speed of 50 meters a second, and how fast is that in kilometers a minute? So first off, let's just think about this real quick, guys and gals. If I'm going 50 meters a second, and I'm changing to kilometers a minute, is my speed, or my number, going to get bigger or smaller? Smaller, right? Because if I'm going 50 meters a second, I'm going 50 meters per 1 second. Well, if I'm making it a minute and a kilometer is a lot farther than a meter, and a minute's not that many more seconds. Like, it's only 60 seconds, right? I'm adding 60 seconds, and I'm adding 1,000 meters. Okay, so just understanding that idea. What conversions does he have to know? He has to know how many meters is in a kilometer. Yeah. How many seconds is in a minute. Okay, but you have to know that. And then we're going to set it up. So here's the initial, 50 meters per 1 second. Kilometers, how many kilometers in a meter? So 1 kilometer, 1,000 meters. How many seconds in a minute? There's your setup. Now here, watch. This is what we're trying to do, guys. This is why you have to use 3 sometimes. Meter, meter, second, second. Sorry, not meter, is minute, wasn't it? No, that's right. Yeah. Oh, no, it'd be this guy. Oh, yeah, we want kilometers per minute, right? Yeah, okay. So I was right. Meter, meter. Okay, so we multiply across. 50 times 1 times 60 is 3,000. And then we have a kilometer on top. 1,000 on the bottom. And a minute. 3,000 divided by 1,000 is 3 kilometers per minute. As I told you, it's going to be a lot slower. Well, it's the same speed, it's just different units. Okay, be a lot smaller number. Okay, all right, so we'll stop there.